Okay, welcome back. Next is Jörg Schad with Mesos. Enjoy it.
So, now you should be able to hear me. Yeah, welcome to my talk about Mesos and DCOS, or Open DCOS. Maybe just a quick poll. How many of you know Mesos? How many have used it so far? Pretty cool. I'm gonna give like a high-level introduction because this is like just a subset of the entire audience. So I hope you don't feel bored at that part. Later on, it's probably also going to be more interesting for you when it goes to like the surrounding environment around Mesos with DCOS. Maybe just let me introduce myself. My name is Jörg. I work at Mesosphere, and I'm basically a committer at the open source project Mesos, so at the core of DCOS. Before that, I worked on databases quite a lot, which I really like this conference because it basically combines what I'm currently doing, like cloud infrastructure, architecture, and databases. Yeah, and let's start why Mesos is a good idea. So, old data centers. And what we actually see also still at a lot of customer sites is a static partitioning of workloads and therefore cluster nodes. So each of those boxes, it's not necessarily like a physical box. It can be like a virtual machine or something. But what we often see when we also go to customers implementing Mesos, we see that they basically have a statically partitioned cluster. Some part is used for Flink, some part is used for Cassandra, some part then for the user-facing Rails application, some for data analytics with Spark, and then some caching. And that actually causes some issues. So for example, when we have nodes failing, all of a sudden there's a rack failure in the Rails part of my cluster, the Rails partition. And now as an operator, I would have to go and manually move machines over deploying Rails, which is one thing I don't want to do. A second problem with the static partitioning is the efficiency. So with a lot of applications, there's a lot of churn throughout the day. So for example, I want to run data analytics at night. My user-facing applications are more active over the day. And by having the static partitioning, I'm actually wasting a lot of resources because I always have to provision for the max load, which could be at a totally different time. And I'm not very flexible. So this leads to overall poor utilization. And I personally would actually like to prefer is that I can actually mix that up so that I can flexibly and dynamically partition my cluster for the different workloads. And this is the one motivation for Mesos. The other big trend we're seeing is like that a lot of stuff gets run in containers. How many of you are using containers for playing or for in production? Okay. So especially like with trends towards microservices, a lot of people are interested in containers, and we're going to see a little bit of that in a second. So for me, my calendar is telling me something. Sorry. So for me, I really like Docker because Docker makes it really easy to run stuff on my laptop. So I can easily spin up a container, but I can just spin up this one container on my cluster. As soon as I get to managing several containers, it actually gets hard. Because how do they find each other? How can I combine them? How can I make sure that there are always enough containers running? So basically, as soon as I want to move from Docker on my laptop towards like Docker in a big cluster, it becomes a lot harder. So for example, till recently, it was like impossible to upgrade the Docker daemon itself without killing all containers. That's like one of the problems. So this is like the other motivation for Mesos, it's container orchestration. where does Mesos actually originated from? So it was actually in 2009, there was a class project by several PhD students at Berkeley, and they had this idea initially called Nexus, which then turned into Mesos. And that was actually given as a tech talk to Twitter. How many of you remember this Twitter fail whale when Twitter wasn't available? For them, that was one of the main motivations to have something where they can much faster deploy something into production and also be flexible in terms of failures. So for, initially for Twitter, it was really, really hard. If they had a new version of their software, it took them like 2 weeks to bring it from development into their dev system, into their production system, which was something they really wanted to improve upon to decrease the occurrences of this fail whale. Yeah, then in 2010, they actually released like the technical report from Berkeley about Mesos together with like the first implementations. And then soon after, in December, it actually moved into Apache incubation as an incubation project. And as of right now, we are like a top-level Apache project. Last week, we actually also open sourced a lot of stuff around Mesos. So you're going to see also throughout the presentation, we view Mesos as like the kernel of the operating system for your data center. And then the data center around with like monitoring, applications, that's what we call DCOS. And that's what we actually open sourced last week. The technology, so from a technology point, why is that messing up in the right corner? From a technology point, Mesos is actually resource sharing. So it's about, the core technology is about resource allocations in big clusters. But the vision is actually so that you can share resources between different frameworks in your clusters, as we saw initially. The vision is actually something more. The vision is the second paper on the right, that the data center actually needs an operating system to control the entire data center. As we are moving from like mainframes to client PCs over virtual machines, and now actually the form factor for which you also want to develop applications, it's usually for many companies, it's a data center. Yeah, as mentioned, Apache Mesos, it's a top-level Apache project, as the name says, and it's actually used by many companies on the right, and actually also at quite big scale. So this is often for me, this is a difference, for example, to Kubernetes. If you want to do container orchestration, Mesos actually scales to 10,000 of nodes. So those are like the largest clusters running, and it's quite fault tolerant and battle tested. It's also, being an open source project, it also has a downside. For any patch we want to introduce, it's a really long review cycle. So introducing new features, it usually takes a little bit longer because all the Twitter guys, they're really afraid that anything might break their cluster. So they're really cautious in what gets merged into the Mesos core and what doesn't. It's also, as mentioned, this vision of the data center operating system is also to have an SDK to build distributed apps. And we're going to see that in a second, a little in more detail. And also the container orchestration topic we saw initially, it's a big issue for many customers, or big motivation for many customers to use Mesos. Mesos, under the hood, it's a two-level scheduler. A two-level scheduler means the decision where to run an application, it's taken at two parts. Down there's the allocation part, which is actually the Mesos part. And this part will decide what framework on top or what scheduler on top receives what resources. So to see like a more concrete example, we could have several schedulers on top. So for example, Marathon is one framework used for container orchestration, so it makes it really easy to run, to deploy Docker containers. For example, saying you always want 100 instances of your Jinx container running. This is something you can easily express by using Marathon. Myriad is yet another framework, and Myriad is actually used for running Yarn on top of Mesos. So if you still have like a Yarn cluster, you can run that on top of Mesos, same as you could do, for example, with Kubernetes. This is like one of the nice features of this two-level scheduling hierarchy. And those schedulers on top, they are basically responsible for deciding what they want to do with resources. So resources, they are offered here down there by these slaves, or we recently renamed them to agents, to be politically correct. And what's happening is actually that one of those agents, it's going to advertise resources to the master. It's going to say, I got 10 CPUs idle here and 10 gigs of RAM. Mesos master, do you want to use that? Then the Mesos master, the allocator logic, is actually responsible for deciding which framework's turn it is. So it's an algorithm called DRF, Dominant Resource Fairness. Talk to me about later if you want to know more details. And in this case, it would basically say it's the turn for the marathon scheduler. It's under its fair share, so I'm first going to offer those resources to the marathon scheduler. And then it's the job of the framework or the framework scheduler to say, I want to use those 10 CPUs you just offered, or I just want to use 5 of those CPUs and start a task there. If it does so, it's going to tell the master, and the master will actually then deploy the task to the agent node. And there we have two instances. So first of all, there's the executor, which is kind of like the watchdog. It's going to start the task. It's going to monitor the task. Usually, if you're writing your first framework or your first exposure with Mesos, you don't even see that because they're a default implementation, so you don't have to touch up on that. And then there are the actual tasks. There could be a one-to-one mapping of executor to task, or an executor could actually run several tasks. And the agent, it's going to report its current state back to the master. So if something happens, like the executor dies, the agent gets their maintenance primitive. So for example, you as an administrator, you can say, I want to take this node offline and replace the hard disk or do maintenance. If that comes, it's going to tell the master, I'm going to drain those tasks. That's again reported back to the scheduler, and the scheduler can actually decide whether it wants to restart those tasks, or whether it's, for example, in the case of maintenance, it's okay to be off, to have this task not running for the next 10 minutes, but then it's most likely going to be back. So this is like the framework logic. And thereby we are actually keeping the Mesos master really simple. So it's just doing the allocation between frameworks. And that's why we actually get this massive scale to several 10,000s of nodes. As mentioned before, this question whether running Yarn as your cluster scheduler, which people usually do if they do like data analytics with Spark or Hadoop. But the interesting part is actually that Spark was initially written as a demo case to show how easy it is to write frameworks for Mesos. But by now you can run it on both Yarn and Mesos and in standalone. It's not a decision whether you have to do either of those. By this two-level strategy, you can actually run it on top, which is quite useful because you can scale up and scale down your Yarn cluster. You can have several multi-tenant Yarn clusters. So you can basically spin up on your physical clusters. You can come up with several Yarn clusters for different teams quite easily and scale them up and down depending on the need. As mentioned, and as we've seen also with the Spark example, the other vision for Mesos is to really make it easy to write distributed applications. During my PhD, we did like several class projects, and it's always like the same. I need to detect which node is offline. I need to decide where I want to run a task. And this is like this common functionality which you basically need for any distributed application. That's one of the ideas of Mesos, to put that into the Mesos API. And that actually allows you to just or more, you still have to write some boiler code, but to really focus on the application logic and not so much like the data center parts, like is a node reachable, is it just a network partition, but it's going to be back in a few seconds. And it actually, when we have a new engineer starting on his first day, we let him write a framework. Most of them finish in the first day, some of them take 2 days, but it's really, really easy to write your own framework. Because you just have to consider those two sides. As we've seen before, there's a scheduler side, which is like on top of the Mesos master, on top of the abstraction layer, which is like the framework part. And that framework part, it has to decide, I get those 10 CPUs offered, what do I do with them? Do I need them? Don't I need them? Do I just need a part? And the second part is, it has to react on task events. So what do I do if that task has failed for some reason? What do I need to do if that task is lost for some reason because, for example, the node has gone offline? The second part, which is optional, is the stuff actually running on the individual nodes, on the individual agents, which is the executor. And the executor is usually responsible for lifecycle management, so it could automatically restart tasks it owns, for example, and monitoring those tasks. Usually, or for the basic scenarios, you don't have to write your own executor because there's like two common executors. There's the command executor, which allows you to run like any command underneath. It can be like just sleep task. It can be any Unix command. You could do Java something, even though with Java I would actually recommend to use the Docker executor and not rely on the JRE installed on the actual nodes. So that brings us to the second part, the Docker executor. The Docker executor lets you run any Docker image, and actually with the new, it's moved from Docker to more like universal containerizer, which is experimental right now. You can actually run Docker containers without using Docker. So it's basically our own implementation of the open source container interface. And so you can actually run them without using the Docker daemon. This Docker executor still uses like the Docker daemon, so it supports all options you can do or you could dream of with Docker. If you're not so focused on Docker, but like on general containers, and you also want to run like Rocket containers, OCI, or anything else, you can actually try out the universal containerizer. I wouldn't use it in production right now, which is why I didn't put it here, because it's still experimental. If now you say you just want to try out and write your own framework or just look at how it's implemented, there's actually a nice project called Rendler. So it's a rendering web crawler. It basically has one task for crawling the web and one then for rendering a nice image, how everything is related. And that's just like a demo framework to show how to write schedulers and how to write executors. It's actually, there are different implementations for most languages. You can actually come up with Java, Python, C++, Go. And I think that's a really good starting point if you want to try it out yourself and just write like your own framework. There are two parts I would like to go into a little more detail. It's basically showing like common problems people are having with Mesos, or where I personally also find the challenges in the open source part are. And one is like container networking. The vision of, as we said before, of Mesos is to just, I don't care on which actual node down there my container or my task is running, which is cool because I'm really abstracting away from the individual machines. But on the other hand, I end up with a problem, how can they communicate? How can they actually discover the different containers they need if I have applications which are composed of several containers? And the old way, which was okay for Twitter, was that actually each of those agents just had one IP address. That meant each container just gets its own port or set of ports, which made the service discovery problem really hard. So first of all, there are of course port conflicts. If I have like a web service which really wants to run on port 80, security if I have production services and test services running on the same agent, they could influence each other or reach each other on the network. Of course, also performance issues. And yeah, as mentioned, this problem of service discovery. How do I figure out where my Cassandra container is running or my database container is running I want to use? And there's a number of solutions, but all of them actually go into the direction of software-defined networking, whereas I believe there's a talk later on about that. And so it segregates the traffic between different applications. So that means A, B, C, D, they are different tasks running on potentially different nodes. And now with network isolation, with a network isolator in Mesos, it's a module, I can actually say only A and B are allowed to talk to each other and only D and C are allowed to talk to each other, which really relieves a lot of those problems. It's easier to find them. Oh yeah, and each of them just has its own IP address by using the network isolation. So this is like a really nice feature, and we're seeing that a lot of the community is also driving this way of more defining the network inside Mesos or by using Mesos. The solution here, this is like one of the many solutions, actually quite interesting because they just basically rewrite IP tables to route the container traffic and then just advertise the routes. And that's actually a pretty neat and pretty easy solution which works on any Linux system. The second part is if we go over to when we have persistence in our frameworks, like the scheduling and also containers. If, for example, if you work with Kubernetes, it's really easy if you're dealing with stateless apps. Stateless apps, you're just going to kill them. You can restart them on any other host. Everything is fine. If I just have my web server, which gets a state from some other system, it's really easy to scale that up and down. But it really becomes more challenging as soon as I work with persistence. So, for example, if I want to implement distributed file system on top of Mesos, if I want to implement a distributed database on top of Mesos. And one of the main problems is, imagine you have your task which has some state. So it could be like the distributed file system, could be the database, or just any other task which wants to persist some state, which it would preferably, even if it dies, gain access to again. The first problem is that as we're abstracting away from all the agents underneath, I wouldn't be guaranteed to receive resources from the same agent again. As mentioned before, the agent is just going to tell the master, hey, here, 10 CPUs, what do you want to do with that? And the master then decides who he will offer it to. And so there's a concept called dynamic reservations, and dynamic reservations, basically the first time I get resources offered, I can say, I want to own those resources. Whatever happens, if that node dies, if I as a framework scheduler die and restart, I don't want those resources offered to another framework. So I want to own them for right now until I release them. So thereby I'm guaranteed to get resources again offered from the same agent. The second problem is that actually by default, for isolation purposes, the task sandbox, so where he can persist data to, is actually garbage collected. And there's also a primitive in Mesos called persistent volume, where I can say, I want a persistent volume which shouldn't be cleaned up and which also shouldn't be in the sandbox for other reasons. The second interesting topic, if we're talking about persistence, it's external volumes. So a lot of people in the Mesos community, they wanted to have storage on which wasn't necessarily on the same nodes Mesos was running on. So for example, like EBS volumes in EC2, which they wanted to access from their cluster. So not necessarily Mesos managed, so Mesos is not going to say, hey, here are 10 gigabytes of EBS storage, but they basically want to be able to use it, so for example, as Docker volumes. And there's like something nice from the open source part from EMC, which is a volume driver isolator module. That's how it's called in Docker. And that actually allows you to just write an app definition. An app definition is something you start up a task with on Marathon in this case. And I can basically just specify some magic variables. And those magic variables, what's going to happen, it's automatically going to create an EBS volume or a scale IO or whatever other backend there is for the volume driver. And I actually like this project so much. I don't like the magic variables here, but I like it because it actually shows that using this modular structure we are having in Mesos, you can actually extend it for so many different purposes. So anyone can write its own isolator module. This isolator module is like storage isolator module. The previous one, it's like a network isolation module. So anyone can just come up with its own isolator modules for its own purposes. This brings us to like the next step, DCOS, and actually, So Mesos itself we view it as a kernel. The kernel, which is basically like in a traditional Linux system, it gives you like these syscalls to launch a task. It gives you some updates, but you need a lot of stuff around for a proper operating system. And this is we have built it as a company together with many partners, but we decided to open source it, as said last week. And so it's about 30, I think we now have 34 open source projects in there, plus like roadmaps designed together with many partners, which actually open source the entire ecosystem around it. So this includes, for example, monitoring. This includes different applications, so different frameworks which are running on top, which make it really easy to use it. And also just like security, anything you need like basically around Mesos to actually run it in production. So Mesos itself, it's easy to set up, but to really run it safely in production, you need like a team like, for example, in Twitter. In Twitter, they have around 5, I think, only by now engineers running that, but it's not like a one-man job to set up like this in Mesos in a cluster. And with DCOS, it's actually possible that one person just tries it out and sets it up for a large cluster, because it actually just has all those best practices by many partners, everyone who contributed to the open source project, inbuilt into DCOS. And thereby, I would actually like to switch to a short demo. So before that, I just started up a demo cluster, actually on EC2. And this is like the main interface. So if you log into the UI of DCOS, this is what you're going to see. And what I find really interesting, or what I find like the core value, is that usually you're not really focused about nodes. So nodes is basically, it's just like a small widget here. But I, as an operator, what do I care about? When do I want to be woken up at night? I don't want to be woken up at night just because one node failed. I want to be woken up if, for example, my task failure rate goes up, or if my cluster is full. So if I have like 95% CPU allocation, that's telling me, hey, something is wrong. I should do something. And this is like what's really driving the DCOS community, is this making it easy for operators to run such cluster. And yeah, the second part I probably care about are all my services healthy. So on this cluster, I actually just installed Cassandra up front, because Cassandra installation takes like 10 minutes. I didn't want to do it in the presentation. And so what I want to see are all the services I'm running on my cluster, are they healthy? This service installation is actually something pretty cool, because anyone can contribute new packages to DCOS. It's like you have on your iPhone, you have your app store, And this is Universe, it's called. It's kind of like the app store for your cluster. So I can just go here. I don't know how many of you have installed like databases or anything on a cluster. And especially if you want to try out something. So again, like being a student, we wanted to benchmark different database systems, and it took us like 1 afternoon to set up each of them. And here it's actually really easy. I can just pick HDFS. It's going to take a while, and let me just check that I have enough free resources. Should work. Good. So I can actually just go here, install HDFS. I can do like, there's like a default best installation, which is just going to put it in your cluster. You can also go to like advanced settings and configure it. That being said, the advanced settings, it's generating a JSON file. And if I'm running a production cluster, let me just click install. If I'm running a production cluster, I wouldn't use this default universe packages. So if I'm running a production cluster, I want to have those JSON files, and we're going to see how we can actually deploy them also by the CLI in a second. And I really want to version them, because any changes, I always want to know what's running in my cluster. So that's what we're seeing like with a lot of customers with their app definitions. They basically, someone writes them, someone deploys them to the cluster. So that would be like one advice. Really, really make sure that you version all this stuff and you have some defined place and some provenance, that you always know what applications are running in your cluster. But for demo reasons, this is actually quite cool to just be able to go here, click, and if I want to be more advanced, I can either go to the advanced tab here, or I can go into more detail by specifying the JSON file myself, which I could also copy from here, for example, as a basic template. Real brief here, just the difference between selected packages and community packages. There are some certification requirements. So we want to make sure that to differentiate what services we recommend to be used in production and which ones not, because they are just not tested that far. And those selected packages, it's also documented in the DCOS project. There's certification criteria, and if you match those certification criteria, you become a selected package. But anyone can also just come up with a community package here. And then if you want to graduate as a selected package, you just need to go through the certification process. And actually, it's really easy to set up your own repository for this app store. It's basically just, you can either clone a GitHub project provided in the DCOS project, or you can also just come up with a folder which has a certain structure. But so also if you run it like internally inside your organization, it's really easy to just spin it up your own apps. So if you're developing your own apps, you don't want to share them with the entire universe with anyone else, which I would still recommend because it's the open source idea. But if you don't want to do that, you can also just set it up as your own instance. So we see here, we actually see the different services. We're seeing that HDFS just turned healthy. This is kind of sad because I wanted to show how it's still installing. But let me just show you the Marathon service. Marathon, let's actually open it in a new window. Marathon is said before, it's both used for container orchestration, but for us, it's like the init system of the cluster. So by default, Marathon is going to always ensure that I have a certain number of instances running. And whenever they fail, Marathon is automatically going to restart them and make sure I always have this number of instances running. And to show that, so let's actually deploy a new app. Mesos, as you've seen before, has its origins by Twitter. So what could we do else than deploy like a Twitter clone. Is that actually readable? So this is just the app definition, and it actually down there has a lot of values which are used for the load balancer, so you don't have to be too concerned about them. But this could also be like a JSON file you use to deploy your services on top of there. So this would be something, as said earlier, I would actually version. So, and DCOS, it also comes with like a CLI, which I installed earlier, and I can just do DCOS. I want to install a new Marathon app, so I do Marathon app, add, and now I can just add this. I hope this command is right. Oh, sure. Does that help? Yep, that looks good. Let's switch back to the cluster UI. We can actually do all this stuff also with the CLI, but it's much harder to see. So yeah, that looks good. The Tweeter app, Tweeter was the name for it. It's running and deployed. And here we actually currently have 3 running instances. So that was one of the parameters which we put in there. Let's see whether this is now available. Yes, it's now available. Maybe like 2 sentences for the structure of this application. So this application, it's like a simple container, which I can scale up and scale down. And the part above the Marathon load balancer is actually the load balancer interface in front of it, which lets me which basically defines the endpoint where I can reach the app. And then there's Cassandra used as the distributed data store for this application. So let's just go here. So we're seeing there's 3 instant. Oh, let's do something first. Let's first tweet. Jörg, hi, OSDC. Tweet. This, of course, is okay, but it's there. I'm not sure what the issue right now was, but yeah, we see the tweet is there. It gets stored in Cassandra, and so we can actually run like our own little Twitter. Being Twitter, we're now hitting a problem, which is those 3 instances, they are not enough anymore to scale my service. So I actually want to scale up from 3 to, say, 6. And now Marathon, it starts deploying them. Usually the first deploy on one node, if you're running Docker, it takes a little bit longer because it's pulling the Docker container, but like the further, so if you're deploying like a Docker app, don't be scared if it takes a while, because it first needs to pull the Docker image and then actually deploy it. So yeah, now we scaled up our service, and the load balancer actually has in the background more more front-end applications to choose from. Maybe just real brief. And yeah, as said, I'm really just using normally in production, I would never use the web UI, but for demos, it's quite cool. And also to get a feeling for it, it's really helpful to just play around with the different options I have. So just showing how we can do different stuff. I can simply deploy like a sleep command, just a dummy task. And we don't need that much memory for it. And we want 2 instances running of that. So now I'm simply deploying like any Linux command. using the command executor we've seen before. But I can here pick Docker images, I can give it different parameters, I can force it to pull it. So I actually have a lot of options available. And then if I've configured all of this and I feel, yeah, this is kind of okay, I can go to the JSON view and actually take care of the JSON. Okay, back. And now as we deployed more apps, if we're going back to the dashboard, we're seeing that the CPU allocation increased, memory allocation increased, and I also, in this sense, I have several ways of controlling that. So I don't want that some intern, for example, probably scales up this tweet app to 10,000, so my entire cluster is unusable. So what I usually do in production settings is something called quota. So I can basically say each role or each entity is just allowed to have that many resources. And the other part, which I can basically also do the reverse. I can set a maximum limit, but I can also set a minimum limit. I can say my HDFS service running in my cluster, I want that always the name nodes have enough resources available, whatever happens in the cluster. So I can set it like a minimal resource guarantee, guaranteeing that always these many resources are going to be available for the HDFS cluster. And if too many nodes are failing, if something else happens in the cluster, what will actually happen is that he is going to shut down other applications which don't have a quota, to always ensure those mission critical services that they are running. Okay. I was faster than I expected. So yeah, this again is the Universe service as mentioned. And yeah, actually I was quicker with my presentation than I hoped, but this gives us just more time for questions. So any questions? Yeah?
Could you explain a little bit more about that? How do you avoid that traffic from all your physical machines is going on the same subnet? And
so basically each application gets its own IP, and then there are different solutions, but what the Calico solution is going to do, it's creating IP table rules, who can talk to whom, basically. So
the IP table rules are created at what level?
On a per node level. So you can just imagine there's like imagine like a framework running, and the framework knows who can talk to whom, and that's actually going to create the IP table rules on a per node basis.
And how do you solve the problem with persistent volumes in Docker if you have two containers that don't share the same volume?
Can you define the problem? You're meaning that both containers are running on the same instance, or yeah? So currently, that's so that would be, for example, that would be the pod concept in Kubernetes, right? So pods in Kubernetes, they share like basically local host and a common network, and in Marathon, actually, right now, what you have to do, you have to define a label. So the first task running would set a label, and then we know that we can only schedule the second container there, but there's soon going to be the concept of pods there as well, and then you would just define they both need to run on the same node, and therefore they can share this mounted volume. In general, what we would recommend is to always back up those volumes by some distributed file system anyhow. so that it doesn't matter too much on which node, for example, if the app is failing and then restarting, on which node it's restarting. Yeah?
Hi. Can I formulate how something like impact zones with Mesos? So I can have 2 data centers and say some application has to run in each data center, or at least 2 instances in one rack or something like that?
This is a concept which isn't like in Mesos core, but it's it's a marathon constraint. You could specify that you're so marathon lets you specify constraints. So I can basically specify constraints. So if I'm coming up here with a new app, is it under optional? Here, I can specify constraints, which could be, I want the different instances of this app running on different nodes so that the host name is unique. I can also specify that they're running in unique, how do you call it, disaster zones or impact zones, yeah.
Hi. Resource-wise, you are running Java to connect Java to Java, and Java being Java, it's quite heavy on resources. So does it mean that you need to have separate infrastructure in order to operate your own infrastructure, or how does it scale?
Which Java part needs to take which Java part? The core of Mesos?
For example, Zookeeper, right? This one is connecting the masters to slaves. It's Java-based. Both masters and slaves are also Java-based. And when you run on top of this...
The master and slaves, they're C++. They're not Java.
Oh, cool. That, I wasn't aware of that.
Cool. Okay.
Thank you.
My daily job is C++ programming, so I'm not a big Java programmer.
Any more questions? No. Everyone is waiting for the coffee. So thank you again.